James, what was the greatest common factor?
2xyz.
Does everyone agree with that? Yes. Very good. Okay. Caleb Dishler, when you take this first term and factor out 2xyz, what's left? You're dividing. You're not subtracting 6 by 2. You're dividing 6 by 2. Very good. Remember, it's division. Parker, what's left in the second term?
-1 x cubed z squared.
Very good. Blake Gotro, what's left in the third term? Just 2. Very good. Don't forget to close your parentheses. And check yourself by redistributing and making sure that those things do multiply out to give you this. Caleb, you would have checked, and if you'd have had that 4 here, when you'd have said 2 times 4 equals 8, that's when you'd have said, uh-oh, did something wrong there. Make sure you check, okay? Multiplying out, we get the same exact problem that we started with. Now, do y'all remember prime factoring, the factorization tree? Where we take things and we break it down to a product of prime factors, correct? What happened if you were asked to factor this? Well, it's already a prime number. So you would say it's prime. Okay? So, what happens if I ask you to take the greatest common factor out of these things? Do they have anything in common? Other than 1? No, they have nothing in common. So what do? I indicate that it's already prime, and it cannot be factored. Okay? That's just, you're going to run into those for your homework, and I want to make sure you know what to do with it. Okay. All right, now, one more thing we're going to cover today is factoring by grouping. Because sometimes you can't pull a greatest common factor out, but you can group some things together and pull that greatest common factor out. Now, luckily, if you look at these right now, there are 4 terms. The first 3 have something in common, right? The last 2 have something in common. But all 4 of them at the same time don't have something in common, do they? All right, well, right now in this introduction, what we're going to do is we are going to group these things together in the goal that when we factor something out of our groups, we will end up with a same expression. And you're going to see what I'm talking about. These are already in order for us. We're going to start by grouping the first 2 and the last 2 terms together. And now, just what we did with the greatest common factor on that last slide, we're going to do that, but we're going to do it twice. First, we're going to do it to this group, the first group, then to the second. So focusing in the first set of parentheses, what do they have in common? A squared. And if I factor a squared out of those terms, what am I left with? A minus 4. Because they both have A's, and they both have at least 2 A's. Take the smallest exponent. Okay? All right, bring down your plus sign. Because you are adding those 2 things together. In the second group of parentheses, what do those things have in common? 3. Well, if I factor out a 3, what am I left with? A minus 4. Okay? Now, I just said our goal in grouping is that when we factor, we get the same expression. Do you see where we both have a minus 4? Okay. Now, look. A term is a single number or a product of things. This is still 2 terms. This is a term, and this is a term, because it's the product of a squared and the difference of 2 numbers, plus the product of 3 and the difference of the same 2 numbers. When I find this answer, won't it be the same as this answer? So don't those 2 terms have a common factor right now? Their common factor is the difference of a minus 4. Now, if I factor that out of this term, what am I left with? And if I factor it out of this term, I'm left with this. And you can check yourself by multiplying those 2 things together, and you will get a cubed minus 4a squared plus 3a minus 12. How would we multiply those together? What would we have to use? Foil. You'd have to use foil. Do y'all want to check and prove it to ourselves?
No.
Too bad. Okay? First times first is a cubed. Outer times outer is plus 3a, but I'm going to put these in the right order. Inner times inner is minus 4a squared, and last times last, minus 12. Isn't that cool?
Yep.
All right. Yes, Annalise. Yes. The rest goes in the second. Yes. Nick.
Oh, how do you get a squared plus 3?
This is what is left when I factor out those other 2 parts. Okay, let me rewrite it because I have all kinds of stuff everywhere. I had a squared times a minus 4 plus 3 times this, okay? Those are 2 terms. They both have this factor in common with each other. So I factor it out, and I divide it or remove it from that. Well, what's left? What's left when I remove it?
A squared plus 3.
A squared plus 3. Okay? So we set that in parentheses. Yes?
What are the same but one's plus and one's minus?
Wait, what now? Oh, if they're the same but one's plus and one's minus, then they're not common. Because one of them is the you just have to leave it like that. Because one of them is the difference between 2 numbers, while the other one is the sum of 2 numbers. Right, let's just take 3 and 1. The difference between 3 and 1 is 2. But the sum of 3 and 1 is 4. That's not a common number. Okay? So they have to be exactly the same. All right, let's look at another example. There is not a greatest common factor in any one of these. But we may be able to group and come up with a common expression. God bless you.